All right, time to get into the math of a one-way ANOVA table. And this is kind of where it gets interesting and complicated. So we'll start easy with degrees of freedom. So here you see we have our ANOVA one-way table up in the corner, and we have our sources, between, error, and total. And for the degrees of freedom for between, it's the number of groups, number of treatment groups, minus 1. The degrees of freedom for our error is the number total, so it's the total number of measurements in all groups minus the number of groups. And then our DF total is the total number of measurements minus 1. Sum of squares. This is where it starts to get complicated and really where the meat of this all happens. So our sum of squares for between is the sum for all groups of ni, the number of measurements in group I, times xi, which is here, you'll see the mean of group I. So the mean of group I minus the grand mean. So the between group sum of squares can be said to be the sum of the number of measurements in each group times the squared deviation of the group mean from the grand mean. Now, SS error, that is going to be across all groups. You're taking each individual measurement minus its treatment mean squared. Okay, and when we're looking at the actual data in Excel, this is going to make a lot more sense, but we're the sum of the squared deviation of each measurement to its group mean. And then the total is very similar to the error. We take each measurement, xij, minus the grand mean. So instead of comparing it to its group mean, it's to the grand mean, and then the sum of the squares of that as well. Okay, mean squares, we're getting easy again. For each of these, between error and total, the mean squares is just the sum squares divided by the degrees of freedom. So for between, it's SS between over DF between, error SS error over DF error, and for total, SS total over DF total. So now we're looking at F, and we only do the F for our between. So we're going to do the F and the p-value here in one slide. So for our between, it's the mean squares of our between, this one here, over our mean squares for our error. And that gives us an F value. Then to calculate our p-value, in Excel we would use a function f.dist.rt. So it's the right-tailed F p-value, the right-tailed probability of the F distribution with the F value that we calculated, so MS between over MS error, with our numerator degrees of freedom being our degrees of freedom for between, and our denominator being error. Okay? So in Excel, f.dist.rt, F between, DF error. And here it is, all in one beautiful table for you to look at. That is what an ANOVA table really looks like. It's really not that difficult, but it takes a lot of space on a Excel workbook, and we're going to see just how much space here right now.